Hello everyone, welcome to the session. I am Pooja and I am your tutor for today at Learn Big. So today we'll be studying mathematics, of course. So let's see what do we have in our topic. Okay, so you might be like thinking we have 1, 5, 9, 13, 17. Okay, so this looks like there's something going on. You cannot see some similarity, or if you can, so what will be the next number? Such questions you get a lot of time. Okay, so let's see. So this is the topic which will be giving you answer to such questions, that if you get any puzzle which is like that it gives you numbers, okay, and such numbers as your puzzle. So how will you solve them? So this is the chapter through which you will get to know that how can you solve such puzzles or questions. Okay, so the topic we have is arithmetic progression. Okay, so you'll be thinking, okay, what is arithmetic progressions? So arithmetic progression is all about numbers. Today we'll be studying all about numbers. So how in different ways we can solve questions, or we can find such numbers which you have on the screen. So let's see what we have, like what are the learning agendas for today. So first we have is #1, that is what is arithmetic progressions. Okay, so of course the topic is arithmetic progression, so you should know that what is arithmetic progression. So first we'll be studying about that. Then the second part, that is the #2, is what is the nth term of an AP. Okay, so wherever you can see AP means arithmetic progressions. Okay, so what is nth term of an AP? So first you understand what is an AP or arithmetic progression, you'll get to know that is the #2 part of the session, that is what is the nth term of an AP. Next we have is #3. So #3 we have is how to find sum of first n terms of an AP. Okay, so again the same. First you understand the #1 part, then the #2, and once you're clear with 1 and 2, you will get the third part as well. Okay, so let's start with the first part, that is #1 of our session. Okay, so #1 is all about what are arithmetic progressions, right? So let's see what are arithmetic progressions. So I'll give you an example. So there was a teacher, okay, and a student. So the teacher told the student that she'll be asking him three questions. Okay, so she told him that for first correct answer, he'll get one chocolate, and after each question, he will get two more than the previous. Okay, so this is quite confusing. The teacher is giving chocolates, but she is playing with numbers right now. Okay, so you'll be thinking that. So the boy was thinking, okay, so he'll be getting a lot of chocolates in this part. Okay, so the teacher is going to ask him questions, and he'll get a lot of chocolates. So he was thinking that so for the first question, whatever he answers, he'll get one chocolate. Okay, so for the first question he gets one. So he was thinking that if I get one chocolate for the first one, so what will, like, the teacher told that two more than the previous, so he was calculating all this stuff. So he thought that, okay, so one he already got, that was the first, so teacher told the condition that one more than the, no, one already he got, and he'll get two more than the previous. So what is the previous number of chocolates that he got? He got one at the starting. That means how many more he'll be getting? Two more. So now he gets three chocolates. Right? Let's see what will be the next one. So now he got three chocolates. That means now how much he'll be getting? Two more. So it will be five. Okay. So you might be observing that there is something similar going on in each part. Like if the teacher asks him more questions, like if she asks the fourth one, so what will be the next term? Okay, so 2 more than the previous. So 5 he got in the previous question. So 2 more. That means he'll be getting 7 chocolates now. Okay, so you can see that there is something going on. Okay, 1, 3, 5. Then you get 7. That means you're able to find out a number. Okay, let's take one more example. So we have a square. Okay, I'll be telling you what is the, like, we got the similar way, right? 1, 3, and 5. So what is that exactly? I'll be telling you after this. Okay, so let's create bit suspense for that. So we have a square. Okay, so with a square, now we make three more squares. Okay, and with this 4 squares, we make, adding them, we add 2 more squares to them. Okay, so we initially had 1 square, then that we took that 1 square and added 3 to them. Then it became 4, and then we took 4 squares and then we added 2 more to them. Let's see what is happening. So you can see that initially we had 1, we have 4, and then we have how many? 6. Just a second. Sorry, actually, there was some network issue. Okay, so you can see that in the first part, we had 1 square. Then in the second part, you will observe that there are 4 squares now. And in the next part, you see that there are 9 squares now. Okay, so what is happening? In the first, it was 1 square. So what is 1 square? That's 1. Okay, if you observe in the second part, it is 2 square. That is 4. And in the third part, you see that's 3 square 9. So if the first one is 1 square, the second is 2 square, the third one is 3 square, and what will be the fourth one? That will be 4 square, right? So in this way, you can find out the answer to this question, correct? So it was 1, then you got 4, then you got 9. So what will be the next number? That will be 4 square, that's 16, correct? So in this way, we can find such answers of questions. Okay, so let us consider some more examples and you'll be clear that what is exactly I'm talking about. Okay, so we have first question, that is 1, 2, 3, 4. Okay, before that, I'd like to tell you that each of the numbers in the list is called a term. Like if you talk about the first question, so the first number is 1, right? So 1 is called a term. So if you talk about the second, this is also a term. Third is 3 is also a term, and 4 is also a term. So each of the number in the list is numbers which are present in a question. Okay, so will be here you have 4 numbers. You might be having more as well. So each of those numbers in the list is called a term. Okay, you have to remember this part. So if you see this example 1, 2, 3, 4, can you see there is something similar going on? Like it was 1 initially, then it became 2, then it became 3, and then 4. That means what is happening? Each term is one more than the term preceding it. What does that mean? That each term is one more. Like if you talk about 1, so what is the next term after 1? That is 2. So 1 plus 1 you get 2. What is the next number? That's 3. So 2 plus 1 is how much? That is 3. And if you add 1 to 3 you get 4. So in each term, so if you want to find a list of this order, you, how will you find? You will add 1 more than the term preceding it. What is preceding it? Like you will add one to the previous number which is there. Like if you want to find 2, you will add 1 to 1. Okay, if you want to find 3, that means you'll have to add 1 to 2. So for each term you'll have to add 1. Let's see for the next question, that is 100, 70, 40, 10. So you can see that here also there is some similar thing going on. Let's see what is happening. So each term is 30 less than the term preceding it. So if you subtract 30 to each term, you get the next term. So if you subtract 30 from 100, you get 70. If you subtract 30 from 70, you get 40. Okay, and if you subtract 30 from 40, you get 10. Okay, so there is something similar going on. Let's see the next question. That is -3, -2, -1, and 0. So each term is obtained by adding 1 to the term preceding it. What does that mean? That if you add 1 to each term, like the previous term. So if you do -3 plus 1, what is -3 plus 1? That's -2. Okay, if you do -2 plus 1, you get -1. And if you do -1 and +1, you get 0. Okay, and if you do 0 minus 1, what number will you get? Okay, you guys find it out now. Okay, so what you have to do is, for the each term, you'll have to add 1 to the previous number. Okay, so the next number we have, the question we have is 3, 3, 3, 3. Okay, so this is very easy. Like you can see that all of the numbers are same, right? So each term is obtained by adding 0 to the term preceding. So if you add 0 to 3, you get 3. If you add 0 to 3 again, so each time you just have to add 0 and you'll get 3, 3, 3, 3, 3. That is list of all the numbers. Okay. For the next question, you have the number as -1, then you have -1.5, then you have -2, then you have -2.5. Can anyone try and guess what is happening in this question? Like what do you have to add or subtract from the previous number so you get the next number? Can you guys tell me? Come on, try it. Okay, I'll tell you. See, so what is the next term will get is, okay, I have got an answer. Okay, so fine. Let's see if your answer is correct or not. So the next number we have, each is obtained by adding -0.5, and that is absolutely correct. The answer which was answered by. Okay, so that is subtracting 0.5. So if you subtract -1 minus 0.5, you get -1.5. If you subtract -1.5 minus 0.5, you get 2. -2 minus 0.5, you get -2.5. So there is some difference which is going on and which is similar to each term. Okay, so in all the list above, we see that successive terms are obtained. Successive means one after the other terms are obtained by adding a fixed number to the preceding one. Like for the previous number, you have to add something and then you get the next number. And for this number, you'll have to add something and you get the next number. Okay, so such list of number is said to be is said to form an arithmetic progression. Okay, so when you get a list of numbers in which they have the same difference, and that is there's something similar going on between the numbers, such numbers are said to be in arithmetic progression. Okay, so let's see what is the actual definition of what is arithmetic progression. So definition is an arithmetic progression is a sequence. Sequence means it is a list of numbers where the initial term and the common difference d are real numbers. Now what does that mean? So initial number, so you can see that the initial number is a. Okay, so you add a difference to each term and you get the new number. Okay, let's see the examples for this. So can you see the first one? So it's 5 comma 8 comma 11 comma 14 comma 17. So this goes on. Okay, so what is the first term that you have over here? That's 5. What do you add to it? You add 3 to it and you get 8. That is the next number. Correct. Again, there's a difference, that is 3, and you add 3 to it and you get 11. Again, you add 3 to it, you get 14. Again, you add 3 to it, you get 17. So what is the next number that you will get when you add 3 to it? Come on, tell me what is the next number that you will get from this sequence. Is it 18, 19, 20? Okay, I've got one answer, and that's correct. Okay, so what is the next number that you'll be getting? You add plus 3 to it and you'll get 20 as the answer. Okay, so whenever a sequence of number have same common, like they have a common difference to it. Okay, so like you can see that plus 3 is the common difference between all the numbers, right? So when they have some common difference, only then they are considered in arithmetic progression. What if the first difference is 3 and the second is 4 and the third is 5 and the next is 2? That means the difference is not same. Okay, and that sequence will not be considered to be an arithmetic progression. Okay, let's look out for some other example. So you have 2 comma 4 comma 6 comma 8 comma 10 comma 12. You can see that the difference between each number is what? Plus 2. Okay, so you have 2, then you add 2 to it, you get 4. Then you have 4, you add 2 to it, you get 6. Okay, then you have again 2, you add 2 to it, you get 8, then 10, then 12. Can anyone tell me what will be the next number for this sequence? Come on, guys, it's very easy. Come on, try it. What is the next number you'll be getting from this? Okay. I've got one answer, and that's absolutely correct. Good going. Okay, so next number will be 14. And what will be after 14? That will be 16. Okay, so in this way the sequence goes on. Okay, let's take some other examples to get this in clear what exactly is an arithmetic progression. Okay, so the next example is this. So you have 3, then you have 7, then you have 11, you have 15, and then you have 19. Okay, so the first term is 3, and you add 4 to it, and then you get 7. Then you have 7, and you add 4 to it, you get 11. Then you have 11, you add 4 to it, you get 15. You have 15, then you add 4 to it and you get 19. Okay, and in this way this series would go on till any number you want. Can anyone tell me what will be the next number after 19? Okay, that was pretty quick. Yeah, and that's absolutely correct. Okay, I would tell that this Joji Joseph is going very great. Okay, so your answer is absolutely correct, and that's the number. Okay, so what will be the next number? That will be 23. Okay, let's take one more example, and I would like if everyone try to give that answer to that question. Okay, so the next number you have is 50, 45, 40, 35, 30. Okay, so what is happening now? You can observe that the difference between the each term is -5. Okay, so in the previous question you were having plus, like the numbers were getting added each time in a series, but this time it's being getting uh, what, subtracted. Okay, so the difference in the first and the second term you see is -5. So 50 minus 5 you get 45, 45 minus 40 you get, sorry, 45 minus 5 you get 40, 40 minus 5 you get 35, 35 minus 5 you get 30. What will be the next number that you get after 30? Come on, tell me. Yeah, that's correct. Okay, so the next number that you will be getting is 25. What after 25? 20. What after 20? 15. What after 15? It will be 10. So in this way, the series goes on till ends. The difference you observe over here is -5. Okay, so what is an arithmetic progression? It is a sequence of numbers in which it can be any sequence. Okay, it can be alphabets as well, like it can be variables also. So it is a sequence in which they have initial term. So initial term is present, and after the initial term the difference is common throughout the numbers. Okay, so an arithmetic progression, the actual mathematical definition is, an arithmetic progression is a list of numbers in which each term, it is what? It is a list of numbers in which each term is obtained by adding a fixed number to the preceding term except the first term. Okay, so whatever number you get the next, okay, so you add a fixed number to the previous one except the first one. Okay, that means if you see this previous example, so you are not subtracting mine, you are not, before 3 you don't have any number, or before 50 you don't have any number, right? So you don't have to subtract or do anything to the number previous than that, but after that number. Okay, so an arithmetic progression is a list of number in which each term, so whatever second term, third, fourth, fifth, whatever term you get it by adding a fixed number to it, to the preceding term. So that was the previous one. Okay. This fixed number is called the common difference. Okay, you have to remember this, that this fixed term is called as common difference. Now remember that it can be positive, it can be negative, or it can be 0 as well. Like we saw an example of 3, 3, 3, 3, 3, right? So when you add 0 to 3, you get 3. Then 0, then 3. Okay, so it can be 0 also. The difference can be 0. It can be negative, which we saw in the previous example, and positive also. Okay, so now if you talk about arithmetic progression, in this, the sequence or the series or the list of number that we talk about is divided into two parts. Okay, that is finite AP and infinite AP. Now what does that mean? You might be thinking about it, right? Finite AP, infinite AP. So finite and infinite, you know, finite means which has end, right? Like if you talk about 1 to 10, so those are called as finite numbers. But if you talk about 1, 2, 3, and it goes on till infinite, so that is called an infinite list. Okay, so has last term and finite term. So what is finite AP? It has last term, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 is the end, and that is the last number, right? And it has finite term, that is they have 10 terms in it. Okay, but if you talk about infinite AP, so in this does not have last term and finite terms. Okay, so it does not have any last term and it does not have finite terms as well. Like if you talk about 1, 2, 3 and then dot 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 dot, that means till infinite numbers, as many numbers as you can. So it doesn't have any last term. Okay, it doesn't have any finite list of terms. Okay, so let's take an example so we'll take the same example. So it's 3, 7, 11, 15, 19. So what happens till 19? 19 is the last number of that series, of that sequence, right? You don't have any dot dot or comma or anything after that. So that is called an finite AP. Infinite AP, let's see an example. So it's 8, 11, 14, 17. So if you add 3 to it, you get 20. Okay. So you add 3 to it, you get 23. Okay, so this list will go on like till you do it. So it doesn't have any end, it does not have any last term. Okay, so this is the difference between a finite AP and infinite AP. Okay, I hope you're clear with this part, that what is finite AP and what is infinite AP. So let's move towards the next part. So there's some basic thing to know about arithmetic progression before we start with the second part, that is the hashtag 2 part. So A1 is the first term. Okay, like if you have the example of 1 2 3 4, so the first term over here is 1, so that is called as the first term. The second is a 2, so that is called as the second term. Okay, so if the list each time, if it is any number, the first is called as the first and the second will be called second, until till the number of till the list of numbers you have. Okay, so the A3 is called as the third term, and AN is called the nth term, or any term, general term, where n is the term position, term number. Okay, I'll be telling you what does this mean. So AN can be any number. Like if you put A7, so it becomes the seventh term of that list. Okay, if you put 10 in place of n, so A10 will be 10th number of that list. Okay, like that. Okay, so let's solve some question regarding this, and then we'll move towards the second part. So which of the followings are AP? Okay, you have to find out. So what we'll do is, the question we have is which of the followings are AP. So 0, minus 4, minus 8, minus 12. In an AP, difference between any two consecutive term. Now what does consecutive term means? Right, the numbers which have common differences are called as consecutive numbers. So if you talk about all odd numbers, they are consecutive numbers. If you talk about all even numbers, they are consecutive numbers, because the difference between them is the same. If you talk about 1 2 3 4 5 6 7 8, they are consecutive numbers because they have this common difference. Okay, so let's find difference between consecutive number. So we'll have, now how will you find out that the list of numbers given is AP or not? Okay, so the first thing you have to do is you have to find the difference between them, and if the difference is common, then it's an AP, and if it's not an AP. Let's check if this question is an AP or not. 0, so minus 4. Okay, let's write this and these in the form of A1, A2, A3, because we have to signify them first term, second term, third, fourth, like that. Okay, so A3 will be minus 8 and A4 will be minus 12. Now A2 minus A1, so if we subtract the second term and the first term, you get the difference. Okay, so A2 minus A1 will get minus 4 minus 0, that will be minus 4. Okay, let's check for the second one. So it is A3, A3 is what? Minus 8, and minus 4. Okay, so it will become minus 8 plus 4, and that will be minus 4 again. A4 minus A3, A4 is 12, so it will be minus 12, minus A3 is minus 8, so it will be minus 8. So minus 12 plus 8, it will be minus 4. So you can see that as the difference is constant, the given list of number is an AP. So this is how you have to find out that the given terms are AP or not. So if the list of numbers is has a common difference in them, then they are considered to be an AP, and if not, they are not considered to be an AP. Let's check another question. So you have which of the followings are APs again. So 1, 3, 9, 27 are your numbers. In an AP, the difference of two consecutive terms is constant. You have to remember this thing. Okay, let's find the difference between the consecutive term. So A1 is what? 1. A2 is what? 3. A3 is what? 9. And A4 is what? 27. Okay, so let's do it again. Okay, you guys try and tell me what is the difference of all of these numbers. Okay, just tell me, are they AP or not? Come on, quickly tell me, are the list of numbers AP or not? 1, 3, 9, 27. Are these numbers a list of AP? Just tell me yes or no. And I've already told you how you have to find. Okay, so I've got one answer, but I'm not going to reveal it right now. Rest of the people, come on, you also tried. Is this an AP? Okay, let's check if this is an AP or not. Okay. So 3 minus 1, that's 2. A3 minus A2. So 9 minus 3 is how much? 6. Okay, so you see, as the difference is not constant, the given list of numbers is not an AP. Okay, so the difference should be the same. Okay, I understand that the answer which you told, that is also correct, but that goes for series. Like if you have any sort of series, okay, so you get 1, 3, 9, 27. So you multiply 3 to each number and you get the number of series. But that will not be considered to be an AP because the difference between the number is not constant. Okay, getting it? So this list of numbers is not an AP. Next we have is hashtag 2 part, and that is, what is nth term of an AP? Okay, so AP, you guys have all understood what is an AP. AP is arithmetic progression. Arithmetic progression in which the difference between the list of numbers should be same. Okay, so nth term of the AP with first term A and common difference D is given by, okay, so what is A over here? A is the first term and D is the common difference. Okay, you have to remember, what first thing is, A is the first term and D is the common difference. How will you find the nth term? So this is the formula that you'll have to use. So AN is equal to, N is any number. Like if you want to find second term, third, fourth, fifth, any term, you just have to put that number in place of n and you'll get the answer. So an is equal to a plus n minus 1 d. That is the formula. So an is also called the general term of the AP. General means, like for example, if you want to add any numbers, so how you write a plus 1 plus 1 is equal to 0. Okay, so if I want to write general way to add those numbers, it will be a plus b is equal to ab. Right, so this is how we write. So for formulas, this is the general way in which you can find any term of any list. Okay, so what does an mean over here? An is the nth term. Nth term means any number that you want to find. A1, like A, is the first term. Then next we have plus n minus 1. So n minus 1, in which n is the term position. So it can be first term, second term, third term. If you want to find the 11th or 100th term, you just have to put 100 in place of n. Okay, and d is the common difference. Okay, so to find nth term or last term of or general term of an AP, so nth term is also called as the general term or last term. Okay, so Tn is equal to, now Tn is what? Tn is again term. Okay, so the formula is just same. So for some people, you'll be in your textbook, you'll be having an is equal to a plus n minus 1 t, and for some you'll be having tn is equal to a plus n minus t, in which Tn is what? Again, the nth term. Okay. A is the first term of an AP, D is the common difference, and N is the number position. So let's see this example. You can see that find the 87th term of the following AP. So how will you find the 87th term? Just put 87 in the place of N. Okay. So 3 is what? 3 is the first term. Let's find the terms. So what is the first term over here? So this is A. Okay, what is the common difference? So 5 minus 3 is 2. 7 minus 5 is 2. And here again 2. So D we get this as 2. Okay, and what is the N you will be using? That will be 687. So TN, or you can also write AN, or like any one you can use. So T87 is equal to 3 plus 87 minus 1, 2. That is, just replace the numbers with the formula. Okay, so when you solve this, you get 87th term of this series as 175. Okay, so this is how they can ask you that find the 90th term of this series, or of this AP, or they'll tell you to find the 15th term or 30th term. Okay, so in this way you can find any number of the series. Okay, if there are only n terms in an AP, then AN is equal to L, where L is equal to last term. So n terms means, like, if the list of numbers is a finite AP. So in that case, AN, that is the nth term, will be the last term, will be L. Okay. Okay, so the next part is, again, I'm just revising this part, that A1 is equal to first term, A2 is the second term, A3 is the third term, and AN is what? It is the nth term. Okay, so I told you that time that I'll be telling you what is it. So it is the nth term. Nth term means any number that you want to find, any term. Okay. Regarding hashtag 2 part. Before that, let's first find the first term and the common difference of some question, so that you can move towards the actual question of finding the nth term. So this is the questions: 3, 1, minus 1, minus 3. Come on, you guys tell me, what is the first term and what is the common difference of these numbers? Come on, quickly tell me what will be the answer. What is the first term over here? Okay. Okay, I've got one answer, and let's see if that's correct or not. Okay, so the solution for given AP 3, 1, minus 1, minus 3. So first term is what? First term of that AP given is, okay. So first term given over here is 3. Okay, so how will you find the first term? Whatever is the first number of the series, that will be the first term. That's it. Okay, common difference. So calculate common difference as a term minus previous term, that is 1 minus 3. Okay, what you'll have to do is 1 minus 3. So in this way, you'll get the common difference. Okay. So 1 minus 3 is equal to minus 2, and that's absolutely correct, that minus 2 is the common difference. Okay. Okay, so what will be the next term of this number? So minus 3 and minus 2 will be minus 5, and that's the correct answer. Okay, so in this way you can find the next terms as well. Let's see if the first term and the common difference of this number. Okay, so tell me, what is the first term and, okay, first term is very easy. Just tell me what is the difference of this series, of this question. Okay, I've got an answer. Come on, rest of the people, you also try. What is the answer to this question? Okay, let's check if your answer is correct or not. So So first term is minus 5. Okay. Then let's see the common difference. So what you have to do is calculate common difference as a term minus previous term again. So minus 1 minus minus 5. So this becomes minus 1 plus 5 and 4 is the answer, and you are absolutely not correct. Okay, so yeah, you have to look out for the minus signs, like the signs as well in the question, because minus 1 and plus 5. So you might be thinking that minus 4 is the answer, but no, you have to put that sign which number has the greater. Okay, which number is greater, that sign you have to put. So 5 is the greater number out of the two, so you'll be putting what? Plus sign for this. Okay, if this was minus and this was plus, then your answer would have been minus 4. Okay, getting it? So this is how you find the common difference. Now let's move towards write the first four terms of the following AP where the common difference and the first term A are given. So they have given you first term and the common difference. You have to find A1, A2, A3 and A4. So these are the terms. Okay, so A is equal to minus 1, that is the first term of that AP. D, that is the difference is 1 by 2. By adding D to a term of an AP, we get next term. That means that when you add minus 1 and plus 1 by 2, you get the next term. And whatever answer you get, if you add 1 by 2 to that number, you get the next term. Okay, let's see the solution. So A is equal to minus 1 and D is equal to 1 by 2. Here, A1 is equal to A, that is equal to minus 1. Okay, add D to the A1 and you'll get A2. So let's see how you do it. So A1 plus D is equal to minus 1 plus 1 by 2. So this will become, okay, now you'll be thinking how minus 2 over here. Okay, so you have to make the denominator same. So here you have 2, so you'll multiply this numerator and denominator by 2 and it becomes 2 minus 2 by 2. Okay, then you take the denominator common now, so you just have to subtract or add the numerator. So minus 2 plus 1, you get minus 1 by 2. Okay, in the same way you have to find the next term as well. So it will be add D to the A2. So what is the A2 over here? Minus 1. So you'll have to add 1 by 2. Okay, and you'll get the answer. So A2 is A2 plus D is equal to minus 1 by 2 plus 1 by 2. Okay, so you can see that denominators are already same, so you don't have to do anything over here. Minus 1 plus 1 is equal to 0, so that is your third term. Okay, so you have got A1, A2, A3, and this is your last term that you have to find. So let's see what. Okay, you guys tell me what will be this last term. Come on, quickly solve this. Like the difference that you have, just add to A3 and tell me what will be your A4. That is the fourth term of this AP. Very, very easy question. Come on, quickly tell me what will be the answer. One, two, three, 4, 0, 3. No, okay, let's see what will be the answer. So here you will have to add D to A3. So A3 is what? 0. So you'll be adding 0 to 1 by 2 and 1 by 2 is your answer. That was so easy, guys. Come on. Okay, so this is very easy. And the same way you have to find the next term as well. Okay, so you guys tell me now what will be the A5 term. They've not asked in the question, but tell me what will be the A5. What will be the fifth term of this series? Okay, so the fifth term will be 1 by 2 plus 1 by 2. That will be 2 by 2 and 1 is your answer. Okay, so in this way you have to find the next terms as well. So the first four terms of the AP will be minus 1, which is already given. Then we found minus 1 by 2, 0, and 1 by 2 is our answer. Okay, let's move towards the next question we have is write the first four numbers of the following AP where the common difference D and the first term are given. So again, they have already given you the first term and the difference. Let's see what are the four terms. Okay, so this is the easiest question. Like is 10, just have to add difference to the each term and you'll get the numbers. Okay, so a is equal to 10, d is equal to 10, your a1 is equal to a and a is equal to 10. A2 will be what? You have to add d to a1, so it will be a1 plus d, that is 10 plus 2, that is 20. Okay, so can you guys try the next number? What will be the next number? You just have to add to 10 to this number and we'll get the next number. Okay, 30, I've got the answer and that's correct. Okay, so in this way, you get the next number. So you have to just add 10 to the previous and you'll get 30. What will be the A4? Come on guys, quickly tell me what will be A4. That is what is the fourth term. 40, yeah, and that's correct. Okay, so 40 will be our next term. So you just have to add 10 to the previous number, so that is 30 plus 10, that is equal to 40. And here we have the answer that the first four terms of the AP are 10, 20, 30 and 40. Okay, so this is very easy question. Okay, so let's move towards the hashtag 3 part of our session, that is how you find the sum of first n terms of an AP. Now, what does that mean? Sum means you have to add. Okay, so suppose you have a list of numbers and you have to find sum of first 10 numbers. So how will you find that? Okay, so this is the formula and this is the thing which I'll be telling you now, that how can you find the sum of first n terms. So n terms can be 100 as well. You have to find terms of that series. You have to find 1,000 numbers or you have to find 50 numbers. Okay, so that can be sum of any given n terms. Okay, so here you have the formula, that is Sn is equal to n by 2 bracket 2a plus n minus 1 d bracket close. Okay, so this is the formula through which you can find, and these are some important formulas like the previous one which I told you and this one as well. So you have to remember this, you have to memorize this formula, because without these formula you'll not be able to solve questions related to sum of first 10 numbers. Okay, so Sn will be sum of a term of an AP. So Sn is what? Sn is sum of, suppose you have to find the sum of 10 numbers. So S10 will be sum of 10 numbers, like that. A is what? A and D will be the same throughout the chapter. Like if A is the first term of an AP, so like you solve any topic of the arithmetic progression, A will be first term only and D will be the common difference. And N will be the number of terms. Okay, we have one more formula for this. So the formula over here is Sn is equal to n by 2 a plus a n. Okay, now you'll be thinking, why two formulas for a single topic? Why can't we solve it by a single formula? The thing is, if there are only n terms in an AP, then an is equal to last number and last term. Okay, so this formula is like this formula is for all the terms, okay, and especially for the infinite ones. Okay, this you will be using for infinite terms and this you will be using for the finite ones. and that is the difference. Okay, so this looks quite easy, like this formula is very easy to solve. You just have to put the number of n and the first term and the last term, just put them in the bracket and you'll be done. Okay, so both these formula you have to memorize them, and if you guys are writing it your book, you can write in your book as well. Both of these formulas are very important to solve the next questions. Okay, so the next part that we have is we have to find the sum of the following AP. So the question they'll be asking us is find the sum of the following AP. So what you have to do is you have to add. Now you cannot keep adding the first term, second term, third term, fourth term, fifth, sixth, seventh, eighth, ninth, 10. What if they ask you 100 numbers? Okay, you cannot keep adding all of them, and because of that we have this formula. Okay, so the other terms are 2, 7, 12 to 10 numbers. Okay, so you have to find the sum of this series till 10 numbers. So what will be the Sn over here? It will be S10. Okay, so we need to find S10 for given AP, that is 2 comma 7 comma 12 dot 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 means it is an infinite series. Okay, so A is equal to 2, D is equal to 7 minus 2. So we'll have to find the difference and then we'll have to solve it. So A is equal to 2 and D is equal to 7 minus 2. So that will be 5. We know that Sn, this is a formula, okay, which I just told you before, that Sn is equal to n by 2, 2a plus n minus 1t. And when I told you the difference, how you can, like which formula to use when. So when it is an infinite series, use this formula. When there is finite series, use the other one. Okay, so we'll substitute n is equal to 10. We'll substitute a is equal to 2 and t is equal to 5. Okay, so S10 is equal to 10 by 2. 2 into 2 plus 10 minus 1, 5. So 10 by 2 becomes 5. 2 into 2 will become 4 plus 10 minus 1 will become 9 and 9 into 5. So this becomes 5. 4 plus 45. So now if you add 4 plus 45, that will be 49. And the sum of 10 terms of this series is 245. Okay, in this way you can find 15 terms, you can 20, 30, 35, 40, 100, any number, any sum of numbers you can find for this particular series and for any other series as well. You just have to know the first term and the difference. Okay, let's move towards the next question. So in an AP, so what have they given? They have given us A is equal to 3. They have given us N is equal to 8 and Sn is equal to 192. Okay, so you'll be thinking, oh, N is given, but Sn is equal to 192. How confusing. So N is equal to 8. That means only 8 terms are present in this particular AP. Okay, let's check this. So solution. So A is equal to 3, N is equal to 8, and Sn is equal to 192. For given value of Sn, let's use the formula. So Sn is equal to n by 2, 2a plus n minus 1 d. So one Sn, they have already given us 192. Okay, you have to find the d over here now. So let's put the value of n is equal to 8. So we'll be putting 8 in place of n, and you get 8 by 2, 2 into 3 plus 8 minus 1 d. So as we don't have the value of d, we'll not be putting anything in the place of d, we'll just be writing d. So 192 is equal to 4, so 2 into 3, that is 6, and 8 minus 1, that is 7, 7 into d, that is 70. So now what will you do is, now this 4 will go on the left hand side, and as it is a numerator multiplication form, on the left hand side it will go in the denominator and the division form. So this will become 192 by 4, 6 plus 70. Okay, now 192 by 4 is 48. So 48 is equal to 6 plus 70 will be as it is. Now take the 6 from on the left hand side. So this will become 48 minus 6, that is equal to 7d. Now you get 42 is equal to 7d, and now the 7 into d, so 7 is in multiplication form with the d, so now you'll take it in the denominator, so that will be 42 by 7, and the value for d is 6. Okay, so this is how you can, like, in the previous one they gave us the series and you just had to find the sum. In this one they gave us the value of sum already and we had to find the difference. They can also ask you, they can also give you the difference, the value of n and the sn, and they'll ask you to find the first term. Okay, so many, like, they will miss out any one thing and they'll tell you to find that value. Okay. So with this, we are here done with the sessions, and do join us for further one-on-one classes, webinars and group sessions. Thank you so very much for being here, and I hope you have understood the whole part of the session, that what is AP, how you find the nth term, how you find the sum of the terms, and see you for the next time in the next webinar, and have a great day, and thank you. Bye-bye. If you guys have any questions, you can ask me. Hello? Yeah, so you wanted to, Joji, you wanted to know about finite and infinite AP. So what does finite and infinite AP mean? In finite AP, we have a list of numbers, but particular, like for example, if you have 5 numbers, okay, so you know that only 5 numbers are present. That's finite set of numbers, okay, because you know how many numbers are there. And if you talk about infinite, what is infinite? There is no end. So if you have 1, 2, 3, 4, so this list will go on till infinite number, and such series are called as infinite AP. Okay.
Could you give me an example about finite and infinite?
Yeah, so like if you talk about finite series, so let's take an example of even numbers. Like this is, I'm giving you the example of a finite series. So 2, comma 4, comma 6, comma 8, and you're done. I'm not putting any more numbers after this. 2, 4, 6, 8, done. Okay, so that means a full stop after that. You know only these many numbers are there. But if I take even numbers, okay, a list of even numbers, that is 2, 4, 6, 8, 10, dot, 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 till infinite. That means no end. Okay, so whatever the number you have, all the even numbers will come under this list. Okay, so these are the examples.
And thank you, ma'am.
Yeah, you're most welcome. Akash, do you have any doubts? You can ask me. Okay. Okay, great. Okay, then see you guys in the next session. Bye. Take care. Have a great day.
Bye.